Hello, my dear students. Welcome to my class Astrophysics. Today's topic is motion in a vertical circle. Let us say body of mass m is tied to one end of a string and rotating in a vertical circle of radius r. Now look at this figure diagram here. It is one object of mass m. It is tied with the help of a string, and it is now this object is rotating in a circular loop of radius r. It rotates in a vertical circle. Let us suppose the body moves from lowest point L of the vertical circle to highest point H. The velocity of the body goes on decreasing because the gravity opposes motion of body. So the body has the minimum velocity at highest point H. In this figure diagram, it is now clear here. It is the lowermost point, that is L point, and when it moves upwards toward the highest point H, due to the work done against the gravity, the velocity gradually decreases. And obviously, at the highest point, the velocity that will be minimum. And let us find out what will be the value of the minimum velocity, is it 0 or not equal to 0, etc. And after discussion, we will find out what would be the minimum velocity at the highest point to complete the vertical circle, and what will be the velocity at that time at the lowest most point. Here, at each and every point, we have to find out the expression for the velocity and also the tension in the string. In this case, the object is moving under the two forces. That means at the same time, two forces acting on the object. Number one force is that is the tension that is acting through the string toward the center of rotation, center of the circular path, and another always a force that is mg, and that is always acting vertically downwards. That means it is subject to two forces, one tension, another mg weight. Therefore, it is not a projectile motion. In case of projectile motion, the object is moving or will move only the under action of gravitational force, only mg. Then it will be a projectile motion, but it is not a projectile motion. You can say that it is a non-uniform circular motion, or it is a, we are studying the dynamics of non-uniform circular motion. Now, when the body moves from the highest point to the lowest point, the gravity helps the motion. So velocity of the body goes on increasing, and hence velocity of body is maximum at the lowest point. That means in the vertical path, vertical circular path, the velocity, that is the speed at a different point, that will be different. That will be not remain same. And obviously at the highest point, the velocity will be the minimum. And when it moves towards downwards toward the lowest point, that is L point, the gradually velocity increases because at that time the gravitational force acting some work on the object. The point L, let us suppose the body passes through the lowest point L with a velocity u. That means at the lowest most point, lowermost point, L point, the velocity the VL, and let us suppose that velocity is the u. And now we have to find out the velocity at any point P. The V velocity of the body at point P, that is any point on this circular path, vertical circle. When body goes from L to P, the body has moved through a vertical distance h. In this figure diagram, it is now clear. When the body goes from L to P in this circular path, at that time there is a vertical height or vertical distance moved, that is the AML in this figure diagram, and that is, let us suppose, H height moves vertically upward directions. Now, according to the law of conservation of mechanical energy, here we considering there is no dissipative force like air resistance, and therefore here we can use the law of conservation of mechanical energy. Total energy at the L, and that is equal to the total energy at point P. And we considering here the L point, that is a zero potential energy point. We are taking the lowest point as a zero potential energy, and therefore at this point it has only the kinetic energy, that is half m into u square. And obviously at point P, that is a height h from the L point. This is height h. Therefore, At point P, the object will possess some amount of potential energy, that is mgh. At the same time, it has velocity, that is the v, and therefore it also possesses some amount of kinetic energy. And according to law of conservation of mechanical energy, we can say the total energy at L equal to total energy at point P. And at the point L, the total energy is a half m into u square plus 0, because 0 is the potential energy. And at the point P, obviously that is half mp square plus mgh, where h is the vertical height or vertical distance between the point P and L. And half m, half m, half m, m, if we multiply it by the 2 and divided both sides of the equation by the m will cancel out, and v square, if we multiply it by the 2 both sides, so u square equal to v square plus 2gh. And from that we get v square equal to u square minus 2gh. That means v will be root over u square minus 2gh. This is the equation. This equation gives the velocity at any point if we know the height of that point. That means at point P it is height h, but at point N, let us suppose at the midpoint here, and at the point N the vertical height will be the r. R is the radius, and at point H the vertical height h will be there is a 2r, where 2r is the diameter of this circular path. Therefore, we can easily find out what is the velocity at point N, at point H, or at any other point if we know the height, vertical height from the lowest point. So it is the formula to find out the velocity at any point if we know the vertical height from the H point. Now another term is the tensions. There are two variables here: velocity v at any point and tension at the different point. Let us now find out. We have to find out what is the tension at the different point. Is it constant or is it variable? Tension in the string. At point P, the various forces acting at point P, that is the weight mg of the body acting vertically downwards, and the tension T along the string. At this point, here there are two forces, mg always acting vertically downwards, and tension T that is acting toward the point of suspension, that is toward the center of the circular path T. Now there are two components, and what is the position of the point P? Now we can consider at that time OP, it makes an angle theta with the vertical line. That means theta is the angular displacement when the object passes from L point to P point. And now this vertical line, and it is also along the vertical directions. Therefore, PL parallel to this line. Therefore, we can say this angle theta, this angle also theta the corresponding angle. Now mg, it has two components. One is the mg cos of theta component, that is opposite to the direction of the tension T, and another is the mg sin theta component. And we already know for any type of circular motion there must be a centripetal force, and here it is clear now the centripetal force always acting toward the center, and the net force here, that will be the centripetal force. Here net force, that will be T minus mg cos theta, because T is acting toward the center of the circular path, and mg cos of theta, the component of the mg, that is exactly equal opposite in direction of the tension T. Therefore, the net force, that will be T minus mg cos of theta, and that will be the source of centripetal force, or that will provide the necessary centripetal force. Now, from this concept, we can write here the mg T is equal to T minus mg cos of theta, that is mv square by r. At that moment, since velocity or speed is the v, therefore the centripetal force at that point P, that is the mv square divided by r, and the component mg cos theta acts opposite to the tension T. Therefore, T minus mg cos of theta, that is mv square by r. And from that we get the equation T equal to mv square by r plus mg cos of theta. And if we know the velocity at that point, and the angle theta, then we can easily find out the tension. That means at this point N, the theta will be the 90 degree. In such a case, mg cos theta will be the 0. And at this point H point, the theta will be 180 degree. And by knowing the value of the V at this point, we can find out the tension at different point. But in this expression, it is also expression for the tension at any point. And there are two unknowns here, theta one unknown and v else another unknown, these two variables. Now we have to find out the expression of the tension with single variables, and that means let us here proceed here. Now from the right angle triangle, if we want to put the value of the cos theta and the v in terms of h is another variable for the different point. In this triangle, OMP, it is a right angle triangle. This angle is the 90 degree, this angle is the theta, and here h is the vertical height. Therefore this OM that will be r minus h, the total distance OL is r, and AML is the h. Then this OM that will be r minus h, and obviously it is r. So from this triangle we can find out the value of the cos of theta. That cos theta that will be OM divided by OP, and that will be r minus h divided by r. That will be the cos of theta. And already we know the velocity v in terms of h, that is the v square is equal to u square minus 2gh. By putting this value of the v square and cos of theta, we can find out the another expression for the tension at different point where the vertical height will be h from the lowest point. Now putting the cos of theta, we have stated above that cos of theta is r minus h by r, that is the OM by OP in the right angle triangle OPOM. Now putting the values of v square and cos theta from equation, the value of the v square we already have, that is u square minus 2gh, and in this equation m v square by r, that is m into m by r whole into u square minus 2gh plus mg cos of theta. The value of the cos theta is r minus h divided by r. And now m by r, if we take the common m by r, here also m by r, that is u square minus 2gh plus g into r minus g into h. And after the simplification, now we get t is equal to m by r whole into u square plus gr minus 3gh. And it is another expression for the tension at any point. If we know the value of the h at the different point, we can find out the tension at that point. That means here in the whole vertical circular path, there are two unknowns. One is the velocity and another is the tension. And there are two formula for the tensions in terms of the theta and in terms of the h. Now for the different point, h will be different and therefore tension will be different. Let us consider that it is the general expression for the tension in the string. Now number one, tension in the string at the lowest point, that is at this point, what will be the tension at the lowest point? Here the value of h is the 0, because we are considering it is the 0 potential energy level. That is h height is the 0 here at the L point. Then tension will be at that point, at the lowest point, h is the 0 by putting the h is equal to 0 in this equation number 5. TL, that means tension at the lowest when the object at the L point, that is the lowest point. At that time, what will be the tension in the string? That is m by r, u square plus gr minus 3 into g into 0. That is the u square plus gr. It is the tension, and it is the maximum tension. Let us suppose now we have to find out that tension at the highest point th. At the highest point, the height h will be 2r. 2r at the highest point h point, that is 2r. So in the above 5 equations, in place of h we have to put the 2r. Then th, that means tension in the string when the object is at the h point, that is highest point, which is equal to m by r u square plus gr minus 3g whole into 2r. Now it is the u square plus gr minus 6 here, that is u square minus 5gr. Now equation 6, it is the tension when the object is at tension in the string when the object is at L point, and it is the value of the tension at point h. Obviously it is far more. Now TL is greater than the TH, because here u square plus gr, here u square minus 5gr. Obviously the value of the TL is more than the value of TH. Now what is the difference in the tension at lowest and highest point? From the relations 6 and 7, we already know that TL greater than TH. Therefore, TL minus TH, that will be M by R, U square plus GR minus U square plus 5GR. And after the calculation we get, that is the 6 mg, M by R into 6GR, that is 6 into M into G. That means the difference in the tensions at lowest and highest point, that is the 6 mg. Therefore, the tension at lowest point in the string is greater than the tension at highest point in the string by 6 times the weight of the revolving body. Here there is no term in this difference. There is no term of the R, no term of the U, no term of the V. That means the maybe the radius of the circular path is quite larger or smaller, and maybe the initial velocity, that velocity at the L point will be different. But when that object completes the circular path, what is the difference in the tension? That is always fixed, that is 6 mg. That depends only upon the mass of the object which is in vertical circular motion. And always it is a fixed value, that is 6 mg. Tension between the lowest point and the highest point of the object, tension in the string, the difference, that is 6 mg. Now, minimum velocity, it is another important term related to these topics. Minimum velocity of projections at the lowest point for looping the loop. Looping the loop means to complete the circular, vertical circular path. For looping the loop, loop here it is noun, also the verb. For the looping the loop, what is the minimum velocity projection at the lowest point? Now, there is a concept to keep the body moving in a circular path. The tension in the string must remains positive even at the highest point, and if TH that is greater than or equal to 0. We already know that at the highest point the tension is the minimum, and that minimum should be not less than 0. That means either greater than 0 or equal to 0 at the highest point, and all other point TH must be greater than 0, that is positive value. Otherwise the string will slack and the circular motion will be not possible. So it is the basic criteria to complete the circular path in vertical circle when TH greater than or equal to 0. Now from this equation number 7, that is TH, if we put this value 0, that is the extreme value, that means lowest one value, that is equal to 0, and we get the necessary conditions. That means M by R whole into U square minus 5GR. It is the expression for the tension in the string when the object is H point, highest point, and that must be greater than or equal to 0. Therefore, from this we can write U square minus 5GR greater than or equal to 0, and or that is U square greater than or equal to 5GR, and this minus 5GR when move to right hand side of the inequations, it will be plus. Just like similar calculation of the equations in equations also we calculate in the similar way. Minus 5GR when it moves to the right hand side of these inequations, it will be plus 5GR. Or therefore U greater than or equal to root over 5GR. That means root over 5GR is the minimum velocity which the body possesses at the lowest point in a circle for looping the loop. That is going around the circle completely. Root over 5GR is the, here it is, you observe there is no term of the mass here. That means for a smaller object or for a larger object, the minimum velocity at the lowest point, lowermost point, L point, that will be root over 5GR or more than root over 5GR, irrespective of their masses. Irrespective of their masses, the velocity must be equal to root over 5GR, and a minimum velocity, or more than the root over 5GR. Otherwise, it cannot complete the circular loop, vertical circle. Now, what is the minimum velocity? The minimum velocity is the L point, and what will be the minimum velocity of projection at the highest point of the loop, or when the minimum velocity or velocity at the lowest, lowermost point, L point, that is root over 5GR. At that time, what will be the velocity in such type of motion? What will be the velocity at the H point? For that, we can calculate it. Let us VH, the velocity of the body at highest point. H is just highest point H in just case of no slacking of the string. Then from this equation we can write V square is equal to U square minus 2GH at the highest point H. h, the small h, that is equal to 2r, that is diameter of the circular path. The h is equal to 2r, that is vh square is equal to u square minus 2g into 2r. And we know at the critical conditions, the u, that is the root over 5gr, therefore u square, that is 5gr, minus 4gr at that point, that is vh square, that is gr, therefore vh equal to root over gr. That means it is the minimum or critical velocity at the highest point. Even if the body is projected with minimum velocity root over 5gr from the lowest point, its velocity at the highest point will be root over gr, not 0. That means the velocity will be not 0 at the highest point. There is a misconcept. Someone think that at the highest point the velocity will be 0, and that is possible. It is not possible. Even if at the highest point, if the velocity is less than root over 5gr, at that time also there will be no such type of motion. Actually, when the velocity is less than root over 5gr, it will not reach at the highest point. And therefore, there will be no questions to have a velocity at the highest point root over gr. It is the minimum velocity at the highest point, it is the minimum velocity at the lowest point, and if the velocity is more than this, then it will successfully complete the circular loop. Condition for the oscillations. Let us suppose the velocity is less than initial velocity at the lowest point, lower point, L point, that is u, that is less than root over 5gr. Then the body will either oscillate about the lowest point L, or the body will leave the circular path. There are two possibilities. Either it will oscillate or leave the circular path. Let us suppose for to find out the condition for the oscillations. That means when it will oscillate and when it will leave the circular path. Uh, Let us suppose the velocity of body becomes 0 at a height h1. That means when it is the less than root over 5gr, then when it moves upwards at a certain height, vertical height, let us suppose that is h1, velocity will be 0 before reaching the point h. And let us suppose that height is, vertical height is h1. The v square is equal to u square minus 2gh1. That is 0 square is equal to u square minus 2gh1. That means h1 will be u square by 2g. U square by 2g at that height, u square by 2g, and that will be the height where the velocity will be 0, let us suppose. Final velocity when it is u is less than root over 5gr in such a cases. When the u is the greater than root over 5gr, there will be no such cases, and there will be no height where the velocity will be 0. Again, let us suppose the tension in string becomes 0 at the height h2 from the equations 5. Now another conditions we can find out from the equation of the tension at different point. Let us suppose at the height h2, at that height, vertical height h2, the tension will be 0. These two height will be not equal. The tension will be 0, maybe at different height. Let us suppose h2 is the height where tension in the string will be 0 before reaching the highest point. So t is equal to 0, m by r u square plus g r minus 3g h. In this case, that is we are taking h2. Therefore, 0 is equal to m by r u square plus gr minus 3gh2. And therefore, u square plus gr minus 3gh2, that is equal to 0. Or 3gh2, that is u square plus gr. And from that, we get h2, that is u square plus gr by 3g. That means at this height, when the u is the velocity at the L point, at this height the tension will be 0, and at this height u is the velocity at the lowest point, at this height the velocity will be 0. Now the body will oscillate if the velocity becomes 0 earlier than 0 tension positions. That means before at the certain height the tension will be 0, and certain height the velocity will be 0, and it will only oscillate when the velocity will be 0 before the tension will be 0. That means h1 less than h1 is the vertical height where the velocity is 0, and h2 is the vertical height where the tension 0. When h1 less than h2, in such a case it will oscillate. That means already we know h1, that is u square by 2g less than u square by plus gr divided by 3g from this equation. And From this, if we cross multiply it, and g cancel out, in both sides g present, and by multiplying 3u square, which is less than 2u square plus gr, and from that we get u square, that is less than gr, or u less than root over gr. That means if the velocity it is less than root over gr, 2gr, then the object will oscillate. And if it is greater than 5gr, then it will complete the circular path. And if the u less than root over 2gr, then it will oscillate. Thus, the body will oscillate about the lowest point of the vertical circle. That is, if u less than 0, less than root over 2gr. If u is equal to root over 2gr, then particle oscillate will be a semicircle. That when the u exactly root over 2gr, then it will oscillate in semicircle. But condition for the body to leave the circle. For this, the tension in the string should become 0 earlier than velocity becomes 0. That means if the tension becomes 0, at that time there is no other forces rather than the gravitational force. Tension 0 means, but velocity is not equal to 0. And what is the condition for it? At that time, h2 less than h1. That means e square plus gr divided by 3g less than e square by 2g. So again calculating it, u square is 2u square plus 2gr less than 3u square, or 2gr less than, it is the plus 1, it is the plus 1 not minus u square, therefore u square greater than root over 2gr. Therefore u greater than root over 2gr, u greater than root over 2gr. Therefore when u greater than root over 2gr but less than 5gr, and if u equal to 5gr or greater than 5gr, then it will complete the circular path. There will be no oscillations. It will move in the circular path. And when u is less than u less than root over 2gr, then it will oscillate. But when the u will be between the root over 2gr and less than root over 5gr, the body leaves the circle path somewhere between n and h point, follows a parabolic path, because it moves at that time under gravity alone with some initial velocity for a short while, and then rejoins the circular path. That means when the velocity at lowest point, that is u, between these two value, after a certain height, after a certain point, the tension will be 0. And when tension 0, it has some velocity also. Velocity is not 0, and it moves under a gravity alone. Therefore the path will be parabolic path, because it is now becomes projectile. For the small time it will parabolic, and after it will rejoin the circular path. But at that time it will leave the circular path. The path will be at that time parabolic, because at that time it only moves under the gravity alone. Now practical applications of the motion in a vertical circle. Let us consider a bucket filled with water. The bucket is rotated in vertical circle of radius r. When the bucket is at highest point along the circular path, then bucket is in inverted positions at this position. When it is moving in this way, at circular path, the bucket it is in inverted positions. Various forces acting on the water at the highest point in circle. The weight mg of the water acting in the downward directions. Normal reaction are by the bucket on the water, which is directed downwards. Net force acting on water at the highest point, mg plus r. Mg is the weight of the water and r is the normal reaction. Both are acting vertically downwards. This force provides necessary centripetal force to the water to move in a circular path at the top of the circle. That means mg plus r. Mg is the weight of the water and r is the normal reaction given by the bucket to the water, and all together gives the centripetal force, that is mv square by r. And from that we get r is equal to normal reaction, that is mv square by r minus mg. The water does not fall out the bucket if r greater than or equal to 0. That means minimum value of that normal reaction should be 0. Otherwise the water fall. That means mv square by r minus mg, that is greater than equal to 0, and from that v square greater than equal to gr, and from that v greater than equal to root over gr. Thus the water in the bucket does not fall if the speed of bucket at highest point at the circle is root over gr. And already we have calculated it. That means to rotate in a circular vertical circular path at the highest point, the minimum velocity there should be root over gr. In this case also we get the same answer. The bucket, the water in the bucket does not fall if the speed of bucket at highest point circle is root over gr or more than this. But as soon as the speed of the bucket at the highest point becomes less than root over gr, then water spill out falls from bucket. Another similar type of examples, a pilot loops the loop without falling at the top of loop. A pilot loops a loop without falling at the top of the loop because the speed of the aircraft at the bottom of the vertical circle is root over 5g or more than root over 5g, and the speed at the highest point of the loop is root over gr or greater than root over gr, where r is the radius of the vertical loop or circle, and at that time it can only complete the vertical circle. Now it is a total concept about the motion in the vertical circles. You will also get different examples of this type of motion in circus. You can see motor rider, motorcycle rider, they are moving in a empty cage in vertical circles, and there also they have to maintain at the lowermost point, that is minimum velocity root over 5 gr, and at the top point the minimum velocity that should be root over gr, otherwise they will fall. And now it is the end of this class, and we will meet in our next class.